All right. I like today's lesson because it is going to combine something that we did already earlier this year, which was graphing lines, and turn it into what we call graphing half planes. Okay? We are doing all of our graphing in the coordinate plane. Now, let me show you something. If you were graphing x is less than 1 on a number line, you would have an open circle on 1, and you would shade that. We're above that now. We are graphing these in a coordinate plane. And basically, what you do is this. X is less than 1. You think of it as x equals 1. You think of it as an equation. Now, when we graph the line x equals 1, don't we know that that is a vertical line through 1? Now, watch this. Over here, when we've got a less than or a greater than, don't we have an open circle? If I have a less than or equal to, I would fill that circle in. It is the same concept over here. I've got a less than. That means the points less than this are going to make it true, but not the points that are on the line. So, when it is a less than or greater than, your line is going to be dashed. A less than or equal to or greater than or equal to, you're going to have a solid line. So your boundary is very similar to what it was on the number line, but it's the line. So, if this was a line, it would be the vertical line that goes through what? Dash, 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 with arrows on both sides. Now, look at the inequality. Where is x less than 1? I shade to the right, because that's where x is less than 1. Do you see why these are called half planes? Because it's half of the plane. So I need to shade one way or the other. When the line is vertical or horizontal, it is very easy to figure out where to shade. When it is not, I'm going to show you how I do it. My older son does not do it this way, and it literally drives me nuts. And he's like, Mom, it's obvious that it's above. I'm like, fine. As long as you know which way to shade, I'm good with it. But I learned it this way, I'm confident with it this way, and I think it's easy. If you don't want to follow the Teresi method, I don't care what you do, as long as it's right. Okay? So, here we go. A linear inequality describes a region in the coordinate plane that has a boundary line. The solution of the inequality are the coordinates anywhere in the shaded area that make that true. Dash is for less than or greater than. Solid, less than or equal to, greater than or equal to. And Mr. Warzonik, naughty Warzonik, is going to go with this. He's going to say less than or equal to is below the boundary line, greater than or greater than is above the boundary line. I don't love that. I like to test a point. Okay? I just don't trust that. It's just mistrust. All right. Now, here we go. I am going to graph this like it was y equals negative 2x plus 1. There you are, Warzonik. You guys just tell me. Okay, I am going to pretend that it is that line. You don't even need to write this, but what you're thinking in your little head is that we're graphing that line. What form is that line in? Hurry up! We got to get going! What form is that in? So, if we are going to graph this, what point do I plot first? 1. That's the y-intercept. What's the slope? So I'm going to go which way? And if I'm going to go, what kind of line am I going to put through this? dash. Do not forget that, because I'll tell you right now, I almost guarantee that on the test, you are going to forget to dash your boundary lines when it's greater than or less than. Now, if we go by Rosonics, he's saying that the shading is going to be up here, because here's our y-intercept, it's greater than, we're going to go up. I am old school. I like to test a point. So, you know what point I like to test? 0, 0, it's easy to work with. Is 0 greater than 1? No, it is not. 0 is not greater than 1. So, would I shade down here? No, I would shade away from that point. Now, if 0, 0 made it true, I would shade towards it. Because, let me tell you, what this half plane means is any point in this shaded area is going to make this true. Let's try a point, 10, 10. Isn't 10, 10 in that shaded area? If 10 is greater than negative 2 times 10 plus 1. I'm going to have 10 is greater than negative 19. That is true. So, that is where the shading is. You see that? Okay, here we go. Now, what form is that in? Standard? No, it's standard. That is standard because 4, 3, and 9 do not have any common factors. This is positive. Quickly. When it is in standard form, you have two choices. I would graph it by finding the x and the y intercepts. Or you could transform it. I personally would not transform it. I graph it the way it is. So, how do I find the x-intercept when it's in standard form? I put 0 in for y. If I put 0 in for y, it's going to be 9/4, which is what, 2 and a 4? How do I find the y-intercept when it is in standard form? So it's going to be negative 3. Now, I'm not doing any flipping of anything, because all I'm doing is finding my 2 points. So, my x-intercept is 2 and a 4, and my y-intercept is down here, negative 3. Am I going to have a solid or dashed line? Solid. Now, this says greater than. So using Rosonics rules, I would go to the y-intercept and shade up. However, let's check it. What point is easiest to test? 0, 0. If I put in 0, 0, I'm going to have 0 is greater than or equal to 9. Is that true? So which way do I shade? There's one that is not true. I'm telling you, I have been doing this for a very, 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 very long time. And when I say something, I'm almost always right. Isn't that what I said? 1, 2, and 1/4. Isn't that what I have? The x-intercept is 2 and 1/4. Right? Now, let's look. Determine whether 4, 1 is a solution. How do I always, no matter what kind of problem we are doing, if I say to you, is this a solution? What do you do? Have Plug it in. Because if it's a solution, it makes it true. This is x, this is y. So, 3 times x, which is 4, plus 2 times 1 is y. Is that greater than or equal to 10? That's 12 plus 2 is 14, is greater than or equal to 10. So yes, this is a solution. Let's do this one. We're going to just do one more. What kind of line is this? Well, oh yeah, but what x equals -2. Vertical line through -2, and we've already said that it's dashed. I understand, but you graph the line like it is equal to. Because that's the line. That's the boundary. And since it is greater than, I dash it. If it was less than, I would dash it. Now, this one, you really don't need to test, because where is x greater than -2? This way. Of course, if I put in 0, 0, is 0 greater than -2? Oh, yeah. You pointed the wrong way. I'm not even paying attention. She's like, graph that way. I'm listening to Emma, and I wasn't even looking at the problem. She goes, go that way. Okay, I'll go this way. Greater than, she's over here. Oh! Did you not point that way? Well, greater than is this way. Now, listen to me. But did you see how Teresa's old school method caught that mistake? Because as soon as I put 0, 0 in, I'm like, wait, 0 is greater than -2. What? I'm shading towards that.